with Stream Connect and trying to see what would be the most efficient way to extract CMDB data to an external system using Stream Connect for Apache Kafka. As I'm presenting Stream Connect to many customers, I often get the question of how could you export the CMDB data. The most efficient way to export CMDB data to send it to Kafka when there is an update or an insert in CMDB table would be probably to create a business rule and use some script within the business rule that's going to produce a Kafka message. But as you can understand, there's hundreds of CMDB tables, so I wanted to see what would be the best design for this. So I'm reusing some of the script, portion of the script that my coworker Bruno has created to export data from tables. I've just modified slightly specifically for the CMDB use case. So here I'm showing an example of a schema for the CMDB. So at the end of the day, we can use the hierarchy of the CMDB to avoid creating one business rule per table when you want to extract data to send it to Hermes, to Kafka. You don't want to create one business rule per table. I mean, you can, but there will be probably a lot of click to do that. So I'm going to show an example here. We have the CMDB _CI _server, and there's other tables that extend from it. So I can actually create a business rule that's going to be triggered on insert and update on that CMDB CI server, and this will inherit from it. In my example, I'm just basically going to make update in the CMDB CI Windows server and Linux server. That must be somewhere here. Well, it's too many on the screen, but you'll see it in my next. Yes, Linux server and Win server. So they inherit from that one. So if I create a business rule here, and my business rule has a script to extract the data from those particular CI, and then send it to Hermes. So before I was always creating one business rule per table, but I figured I can save a lot of time if I have one only business rule on the parent table, and I will take care of the child. I will take care of the child table. So that was kind of my idea. So what we have for this, using a script that I've probably demonstrated to most of my customers. That script came from one of my coworkers from our customer outcome team, Bruno. And as I said, the way this has been designed, I think it's neat because that script is generic enough. So here I'm showing on a business rule on the parent table, the CMDB CI server, right? And the way Bruno has designed this and his team is to decide what field we want to include in the Kafka payload. We're maintaining system properties. So for each table, we create a system property that's going to contain the list of fields that we want to include in the payload, right? In the future, maybe ServiceNow will provide some better way to do this, but that's the way we can do this today. So we may provide better option to do that in the future. I don't know yet. So what that script does, my idea, and it's quick and dirty testing, so don't use this for production stuff. But here, basically, in that script, I'm capturing the name of the table I'm working from, because I don't know in that context yet if that business rule was triggered for the parent table or the child table. So the first thing, kind of what I do here, is getting the table name. And once I get the table name, I'm dynamically generating the name of the system property I'm looking for, because in our naming convention, the system property will kind of always be named like that. It will start with a string like this, but in the naming convention I decided the system property for the table will contain the table name, but instead of the underscore, it has dot. So it's just, you can change this to the way you want. This is just the way I decided to do. So I'm just doing a replace of the underscore by a dot, and I know I have my system property that I can look for. I do a bunch of logging there. What else do I do? Yeah, I think that's it. Yeah, I modified a script that I was given by my coworker here in the header of the Kafka payload to do the triage from the consumer side and know, okay, we're getting CMDB data is coming from which instance, which table, and is that an insert, an update, or delete? So I modified that portion of the script here to detect if the business rule was triggered on an insert or on a delete. And that was a question I've received from a customer. So I try to do this with a function, and that works. I use this, and that works pretty well. So now I can dynamically in my header tag if it's an insert or an update. And then the rest is just basically producing the Kafka message here with that function. And here we decide if we can find the system property, we're going to use the field that are referred in the system property. If we can find the system property associated to that particular table, we then use all the field available on that record. So that's the way this was designed by my colleague. So now we can test it, and so you can see here I only have that business rule, and it should work for no matter what, for any single child table under that CI server. It will capture the Kafka message. So I will display on my screen, maybe I will use a Kafka consumer script to show you in real time when I modify a CI what's going on. And we can go inspect a little bit using topic inspector. I'm gonna reduce the size of that screen here, and I'm gonna try to put the Kafka consumer script in there so you can see in real time. Here we go. Here we go. There we go, there. Hopefully that will work. Okay, Kafka consume. Just it's a script that I use a Kafka consumer script anyway. So let's modify a CI. So and then we can create. So we can look at both. I'm going to so I have a very simple CI in the Linux server CI table. See. So I'm on the Linux server CI, and I can modify a field. I'm gonna modify the name Quentin demo 123. Well, this is obviously an update. So that works. You can see in real time the update is captured, even though the business rule is on the parent table, it's still captured. And I can do this on the Windows CI. So I'm gonna go on the Windows CI. Gonna change the name here. I'm gonna put SAP Quentin. Demo doesn't really matter. I'm updating whatever field that should trigger the update here. Right? It was captured automatically, the change. So this is to prove that with one business rule, we can capture change on all the child table. And also we can be smart in what field we want to use for this or that table, what field we want to capture. So maybe I show this to you, the field I'm capturing. If here, for example, for each of the table, obviously I'm maintaining this. A system property, I have my own naming convention for each. Here for the CMDB CI Win server, I define here, I want a name, field, IP address, operating system, manufacturer. Well, this is case by case depending on the use case, but here I'm just selecting for the demo just a 5-6 field to extract. And if we can't find the system properties, we just throw all the field available and value in the Kafka payload. So that is that. When I've modified, I'm dynamically tagging if it's an insert or an update in the Kafka message in the header. So for this, we can look at that here. If I change, I'm in the Hermes topic inspector because from the Kafka script I'm using, I cannot read the headers. So I'm just gonna show you the header from the instance. So if I change the time here and I put when was my test, I'm just gonna put 18 just try to display some of the message we just produced from the instance. Should be able to look at the header. And I'm showing this in the video because there was a question from a customer yesterday, so I just want to tackle that in the video so I can show, because the customer was asking, how do you know if it's an insert, update, or delete? Well, that logic, I've put it in the script, so in the business rule, so I can identify if it's an insert, or delete, or an update, and then I can show, I can put this in my header, so if whoever is the consumer of that data can put some logic and understand if it's an insert or an update. So I'm gonna click on the Kafka message. So here we see it's an update for the CI that I modify in the CMDB Windows servers here. So this is where we show the value. So it was an update in the Linux server. And if I create an insert, it will show, if I insert a new record, it will show insert in the header. So that's what Kafka consumer can use to route the message accordingly and do whatever they want. Right, so here I can click on the payload and you can see the payload exactly the same as here. So yeah, I'm gonna go back to the script maybe, but that's all I wanted to show. It's just a simple example. I have a business rule on a parent table, CMDB CI server, and in the demonstration you saw that I modified the Linux, CR Linux table and Windows table, and he still extracted data. I only have one business rule on that table. So the reason why I was trying to try this is because we would not want to create 200 tables if we have 200 CMDB CI tables. So if we're smart about it, we can identify the right parent table, and then we should be good to go. Also, if you create many business rules, here the script is generic, so you could have this in all of your business rule, but maybe it would be better to put that script in a script include and have your business rule call that script include, so you don't have to copy paste a bunch of script. Right, easier to maintain. All right, that was it for today.